So in this video, we're going to go through a complex familiar question that was sent in to me by a student. And this is something that I guess I kind of missed in my earlier videos. So we've got Genevieve's superannuation account has a current balance of that and pays interest at a rate of 2.8% per annum compounding monthly. Her employer deposits $580 into this account every month. How much money will Genevieve receive from this account if she retires after 4 years? So there's two approaches when it comes to this question. The first approach is to use the annuity formula plus compound interest. The second approach is going to be to use the recurrence relation. So because we've got $175,264.26, we've already got that much, right? So that amount is going to be going up with interest, and the deposits that we're making is going to also be going up with interest, right? They're both going to have interest added onto them. So what we can do is we can essentially set up this question by combining the compound interest formula and the annuities with regular deposits formula. So there are situations where we can combine two formulas. So the first part, the blue part, that's going to link to the compound interest formula, because that big lump sum of 175,000, that's still going to be impacted by interest. So that's going to go up with interest. And then all of the deposited amounts are also going to be going up with interest too. So interest is applied to both situations. And how you could think of this, you could think of this as just two separate accounts that are being added together in a sense. So you've got the lump sum of 175,000, that's kind of on its own, and then you've got someone depositing $580 regularly every month, and then essentially you're just adding those two up. So first thing we're going to do is we're going to define our variables. All of these just come straight from the question. Lowercase I is 0.028 over 12, which is just the interest rate as a decimal per compounding period. N is 4 times 12 because we've got 4 years and it's monthly. M is 580, which just comes straight from the question. And the principal, or the starting amount, is $175,264.26. Now what we need to do is we just need to substitute and solve. So once we plug all of that in, it's a pretty long formula, but we're just substituting everything in. We're entering all of that into a calculator, and we get this amount here. So $225,432.40. So this is the way that the textbook did this question. I'm going to show you a different approach, and this is the approach that, in all honesty, I think I would use this over the first approach. But either way, in my opinion, I would argue it should be full marks. So the second approach is using the recurrence relation for regular deposits. So I'm just going to write out my recurrence relation formula. I've got to work out R, lowercase r separately, which I've just done on the screen there, and my deposit amount is $580. So that's my recurrence relation. I've just substituted R and D. And in this case, my starting amount, AO, is 175,000, etc. So because this is monthly for 4 years, that means I've got to find A48. Just a quick typo too, I had a minus before. That should have been a plus. So there should be a plus in this recurrence relation, not a minus. So when I find A1, if I plug everything into my calculator, that's what I get for A1. As we'd expect, the total balance has gone up slightly. And then for A2, I could do the same thing, but just using the answer feature. And now I can just repeat this on my calculator using the calculator trick until I get to A48. So once I do that, A48 equals $225,432.40. And as we can see, it's the same value. So either way, whichever method you use, you get the same answer. So just to summarize, when investing a lump sum plus doing regular deposits, we can use either formula. We can use a recurrence relation where AO is the lump sum, or we can use the compound interest plus the annuity formula next to each other. And notice that if you do in this situation, you get the same thing. So these sort of questions would definitely be something that you could see in the complex familiar part, or even I guess complex unfamiliar parts of your exam.